Dr. Kenneth Scheppke is board certified in both emergency medicine and EMS. He has been practicing emergency medicine for over 25 years and serves as the State EMS Medical Director for the Florida Department of Health, as well as the EMS Medical Director for 6 fire rescue agencies in Palm Beach County, including the town of Palm Beach. Dr. Scheppke is a nationally recognized expert in EMS and has been involved in the state's COVID-19 response since the beginning of the pandemic. And along with his background in emergency medicine and biochemistry, he is highly knowledgeable and informed in the development of the many vaccines on the horizon to prevent COVID-19. Here's Town Council President Maggie Zeidman and her eye-opening interview with Dr. Kenneth Scheppke.
Can you tell us what are the different types of vaccines, what's messenger RNA, and how do they work on our immune system?
Sure. So the messenger RNA vaccine is the newer technology, and I don't want to say brand new because it's been around for actually 30 years, but it's really been in the last 10 or 15 years that there have been some major medical breakthroughs using messenger RNA as a vaccine. The Pfizer and Moderna vaccine candidates are both in for emergency use authorization now. We should be hearing from the FDA basically in the next week or two on whether or not they'll receive emergency use authorization. They have almost identical technology in that these are not viruses. Typically in the past, vaccines were made out of viruses, but this is not a virus at all. This is a man-made lipid nanoparticle. And basically that's fancy words for it. This is a little tiny ball of fat. And into this little tiny ball of fat, they put this molecule we call messenger RNA. And what messenger RNA is, it's basically a strip of genetic material that encodes for a protein. Our body makes antibodies to proteins. So whatever messenger RNA you put in there, that goes into that little lipid nanoparticle. They inject you with that, and that gets into the body cells. And then once the messenger RNA is inside the body cells, the cell's machinery takes that messenger RNA and reads that as a recipe and creates a protein. And that's important because your body's immune system can recognize proteins that don't belong. And so we use that messenger RNA to encode for the spike protein in this case. So when your cells start making the spike protein at the site where you were injected, your body's immune system say, hey, that doesn't belong here. And they start creating antibodies and T cell immune response to that spike protein. And that's how we can develop immunity to the COVID-19 virus without ever being injected with the virus. So AstraZeneca and Johnson & Johnson are the next two that are up. They use a little older technology where they actually use a virus, something we call an attenuated virus. In this case, it's in the AstraZeneca product, it's a adenovirus that causes a cold in chimpanzees. And they modified the virus genetically so that it cannot copy itself. And then they added the genetic material that encodes for the spike protein. So again, we're targeting the spike protein. And then when you get injected with this vaccine, that weakened virus attaches to your cell, injects that genetic material into the cell, and then again, the cell's systems take over and converts those genetic messages into the spike protein. So we did see some news from AstraZeneca. They published some early results. It's also effective, not as effective as the messenger RNA vaccines. Both of the two messenger RNA vaccines we found had a 94% in Moderna and 95% efficacy in the Pfizer product. Johnson & Johnson is also an adenovirus vaccine. That's also in the pipeline. We expect that early 2021, those two companies will apply for emergency use authorization. And then the last one for the United States, at least, I mean, there's lots around the country being developed, but in the US, we've got 5 of them. The last one is the Novavax candidate. And that one's not a virus either. That one's just a piece of the virus. In this case, it's purified spike protein. Purified spike protein is going to have to be combined with something else that stimulates the immune system, something we call an adjuvant, because the protein alone doesn't usually stimulate a really robust immune response. So that one will be combined with the adjuvant. And so far, early results from that look good, but they're not quite as far along as the other. So that won't be until later into 2021 that we see those guys apply for emergency use authorization.
I think, Dr. Scheppke, if it's okay with you, we better start with a primer if we're going to talk about vaccines on the ACE2 receptors. So take it away. Tell us about that.
So when a virus infects our body, it needs to be able to attach to our cell somewhere. And the ACE2 receptor is where the virus that causes the COVID-19 disease attaches. The ACE2 receptor has certain functions in our body unrelated to this infection. And the virus just basically developed in order to exploit that ability to attach that particular protein that exists in our cells. Now, this particular receptor exists on lots of mammal cells, which is why you can see this particular disease cross species. The protein of the virus that attaches to our cell at the ACE2 receptor is called the spike protein of the coronavirus. And that is where we want to target our immune reactions, because if we can attack those spike proteins, then we can basically cover up all of those attachment points so that the virus basically becomes inert and is unable to attach to our cells. That's one of the focuses when you look at all the various vaccines, is to attack that spike protein that attaches to our ACE2 receptors.
Are those ACE2 receptors found all over the body?
That's a great question, because the location of those receptors kind of gives you a clue as to what kind of symptoms you can get. So certainly they are in the respiratory tract, which is why you get a lot of respiratory symptoms with this. But they're also found in lots of other organs, such as the gut, which is why you see a lot of GI symptoms like vomiting, diarrhea with this, abdominal pain. They're in the kidneys. They're in the heart, which is why this can actually cause something we call myocarditis and even heart attacks. And very importantly, they are in the blood vessels. And that was something that we learned early on in this disease, that this was not acting like a normal respiratory disease. It seemed to be much, much more than that. And that's because this thing causes that all those different organs to be infected, and especially the blood vessels. And when that gets infected, it causes these blood clots. And so we were seeing this as a really big problem, and a big issue that we needed to deal with was blood clotting all over the body, in the heart causing heart attacks, in the brain causing strokes, and in the lung, basically thousands and thousands of tiny blood clots in the small blood vessels of the lung, causing a drop in our oxygen levels in patients that are infected with this.
Is there anyone that shouldn't get the vaccine?
So we still have as you can tell, just watching the news, this is a rapidly changing topic, and we're still learning a lot. So there are definitely still some unknowns when it comes to this. Folks that have autoimmune diseases and are immunosuppressed from other reasons typically have to be a little bit cautious about vaccines, particularly getting vaccines that have live viruses in them. Because while a weakened live virus doesn't normally infect, it's not usually strong enough to infect somebody within a normal immune system, if you have a weak immune system, it could potentially or theoretically cause a disease in you. The nice thing about the messenger RNA vaccines is that they are not viruses at all. They can't infect anybody. They can do one and only one thing, which is encode for the spike protein, and then that's it.
So what if not everyone gets the vaccine? What happens about herd immunity then?
Yeah, so we don't need everybody to take it. So you're absolutely right. That's the concept called herd immunity. Now, you can get herd immunity by allowing everybody to get infected naturally, and that's not a great way of doing it, because a lot of folks will have long-term illness or organ damage or even death from this. Or you can get herd immunity by vaccinating a certain percentage of the population, and it varies. The percentage of population that needs to be immune varies by the infectiousness of the particular disease. In this case, COVID's fairly contagious. So experts are estimating that we need 60 to 70% of the population to be immune to kind of get this to stop transmitting.
Period of time was shortened to get us to where we are with these vaccines. And some people are afraid that maybe not everything was done that should be done. Could you address that for us?
People think because we got here so quickly that there must have been some corners cut. And that's not the case, actually. It's especially in the case of these messenger RNAs. And the exciting thing, it's hard to say this exciting with such a terrible pandemic, but we've really seen major medical breakthroughs with these messenger RNA vaccines. We will forever be able to make vaccines quickly now because of this new technology. Moderna and Pfizer have a 94 and 95% efficacy rate, respectively. That's grand slam efficacy level. I mean, if you just look at some of the best vaccines we've had in human histories, like measles, that's upper 90%. A typical vaccine, like the influenza shot we get each year, averages only 40%. That's 40% efficacy rate. So to have something that is this highly efficacious, that's absolutely fantastic. It's much better than we were even our wildest hopes would be for this vaccine. So it looks great for the future for us.
Are there any side effects to the vaccines that you know of?
There are, and that's so. Again, to the Moderna and Pfizer, I'll talk about them because they're coming out first. The side effects were relatively mild and generally occurred after the second shot. Both of these are 2-shot series. I mean, you'll get the first shot today, and then you get another shot 3 or 4 weeks later. And it's with the second shot that you typically see some typical stuff that you get with lots of vaccines. You might be a little achy, you might have a low-grade fever, might get a mild headache, things like that. Generally, they were mild, self-limited, got better with Tylenol, lasted 1 to 2 days. So relatively minor and common with lots of other vaccines.
Now, with the Pfizer vaccine, and to some extent Moderna too, the special handling is required, freezing basically. So with something like that, how do you see that being rolled out to the general population? How will that be distributed?
Well, the Pfizer especially has to be stored at negative 80 degrees centigrade. So this is not your normal kitchen freezer that we need. Now that's for long-term storage. You can actually put it in a regular refrigerator, but that only lasts for 5 days. And the last thing we want to do after we've been waiting this long for a vaccine is let a vaccine expire. So we are going to, and we already have positioned these special freezers around the state where we can store the vaccine, and then we'll do secondary distribution to the folks that are going to be giving the shots in the arm, so to speak. Moderna will probably be a little easier because while that does need to be frozen, it doesn't need to be frozen to as cold a temperature. And you probably use just a regular freezer for that. And then that really opens up a lot of distribution sites for it. So I see this as a well-coordinated storage area where there's going to be depots around the state with the folks that have these various cold, ultra cold freezers, and then with secondary distribution to the points of where we'll be using it.
Would you consider, I think I saw this in one of the great films that you've done to educate people and educate EMS, the paramedics, using the testing sites as actual vaccine distribution sites?
Absolutely. So and there'll be multiple models for mass vaccination, but one of them, just like we're doing mass testing where folks drive up and we do a swab of their throat or their nose, well, we'll just we'll change out the swab for a shot in the arm. So the same mechanism, you drive up, we'll do some clerical stuff to get your name into the database so we can track you, let you know when you need to get your second shot of the vaccine. And then we just give you the shot in the arm.
We're going to head over to the more local level now to see what Chief Donato has in store for this community itself.
And Dr. Scheppke, and you spoke earlier about the mass testing sites. And, and so while everybody needs to get vaccinated, we're hoping to take some of the burden off of those mass testing sites by providing very localized vaccinations here in our community in settings that people are comfortable with and familiar with here in our community. And we do that through what's called a closed pod. We've trained all of our paramedics on the requirements for vaccinating folks. And then we've got agreements and MOUs in place with the county health department. And we've got the go-ahead from the state. We registered in the Florida shot system to be a vaccine provider. All that was put in place, and we're ready to go. We've seen a large uptick in the number of cases in our community. That's to be expected somewhat with more people coming back to town. But we can do something to reduce it. As individuals, we can make a difference. And I just ask for the next couple of months, you do your part. Protect yourself, protect your family, protect your friends, and protect those in the community.
Thank you, Chief. That's the message. And thank you both. Thank you, Dr. Scheppke. Thank you, Chief Donato.